In this video, we will be discussing negations, conjunctions, disjunctions, the three different types of conditionals, biconditionals, and truth tables.
So much stuff to study for, and I have no idea what I'm doing in geometry. And I have a quiz Monday.
What kind of teacher gives a quiz on Monday?
My math teacher.
Oh. Well, what's it on?
Like truth tables, negations, and stuff like that.
Oh, I did that last, so I can help you.
Thank you.
So how have you been studying for this exam?
With my textbook.
It's pretty helpful. Don't use a textbook. The thing you need to know for like part of the vocab is negations, and negations are the opposite. So think of the word positive. What's the opposite of positive?
Negative.
Okay, so now think of the variable p. What is the opposite of p?
Not P.
Yeah, so that's the negative form of p.
Wait, so I don't get what a conjunction is.
Okay, well, conjunction is defined as a compound statement using the word and a helpful hint was that think of conjunction as a con artist. They're always having two ways to get you.
Get disjunction.
Okay, well, disjunction, just like conjunction, is a compound statement using or instead of and, like conjunction uses and a helpful hint for that would be, think about when you're dissing someone, usually only one of the statements is true, so it's either this, they're either like this, or they're either like that, and one is true. So just like disjunction, you're saying that one's true or that one's true.
So at least one of them is true. The negations meaning opposite of P is not P, and of Q, not Q. The conjunction of P and Q in symbolic form is disjunctions use the term or. Disjunctions of P and Q in symbolic form is P or Q. Conditional is if P, then Q. A conditional statement in symbolic form is remember, in a conditional statement, it goes hypothesis, then conclusion. Converse meaning you flip the conclusion and the hypothesis. The converse of P then Q is Q then P. Inverse is when you negate both the hypothesis and the conclusion. Inverse of P then Q is not P then not Q. The contrapositive is when you flip and negate the hypothesis and the conclusion. The contrapositive of P then Q is not Q then not P. Biconditional is if and only if. A biconditional statement in symbolic form is P and only if Q. A common mistake that is made between a conditional statement and a biconditional statement is that a conditional statement has one arrow pointed towards one side, while a biconditional has one arrow pointed to both sides, one-sided arrow and a double-sided arrow. A negation truth table starts off with true, then false, and obviously the opposite is false, then true. The common pattern for a truth table is true, true, false, false for the P column, and true, false, for the Q column. The P is true, true, false, false, and then true, false, false. Because a conjunction is and both must be true in order to be true, true and true would be true, true and false would be false because one is true and one is false. Same with this one, and because these are both false, this is false as well. Pattern for a P column is true, true, false, false. Q column is true, false, and for a disjunction, only one needs to be true, at least one, which is because it's an or. These are both true. This has at one least true, so it's true. One at true, and these are both false, so it's false. P column is true, false. The negation of P is false, true, and because this is an and statement, you do true and false, that they're different, so they're false, and they're different, and then there's false. This, together, because they're both false, is known as something called a contradiction. For a Q column, start off with true, then false. The negation of Q is false, then true. Because this is an or statement, at least one needs to be true. It's true. This is true. And these are both true, so it's also known as a tautology. As a helpful hint, remember that both true is a tautology and both false is a contradiction. So this is a little bit of a harder problem. You can start off with true, true, false, false. Q column, true, false, false. To the negation of Q, so opposite, false, true, true. Then you have to do the P or not Q. So you look at just these two columns and you do at least one's true, so it's true. Both are true, so it's true. Both are false, so it's false. And well, at least one is true, so it's true. This is a little bit of a harder one. As you start off, you start off true, true, false, false. Then true, false, false. Then you do the not P, which is opposite of P, so it's false, false, true, true. Opposite of Q, not P, not Q, false, true, false, true. And you take these two columns because it's an and, it's not P and not Q, both false, so it's false, 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 true. This one's a lot harder one, but it's manageable. So if you were to start off step by step, start off with true, true, false, false. Then your Q column as your true, false, false. Not P, false, false, true, true. Not Q, false, true, false, true. Then you take the and of your Q and not P. So you have a false, it's an and, false, true, false. Then you take the not of this one, which is the opposite of this. So it's going to be true, true, false, true. Then you have this, and you take the P column or not Q. So you have at least one's true, so it's true, true, false, true. Then you have the not of this column, so you do the opposite, so it's false, false, true, false. Then you take these two combined, and you do it with an or. So you have true and false, at least one is true, have least one, least one, least one. This even ends up to be a tautology.